Today we're going to be looking at exponent rules, and we're going to go over the 6 different types. So the first one is adding and subtracting monomials. And if you remember what that rule was, it was combining like terms. So do not change the common variables and the exponents. What that means is I'm not going to change this x squared and this y. The reason why is because I have 9 sets of that x squared y minus 10 sets of x squared y. So only number I'm going to change is 9 minus 10, which would give me a -1. And, oops, I'm going to leave the x squared and y there. So there's our first example. The next rule down here is the product rule. This one is really important to remember. So if I have x to the power of a times x to the power of b, what I'm going to be doing is essentially adding those exponents together. So I'm going to add the a plus the b. Remember, we drew this giant plus sign here, and that's how we did it when we learned it previous. So I'm going to look over here, and I can see that I need to take this -2 and multiply it by this 7. So a negative times a positive is a negative. 7 times 2 is 14. Okay? So remember, now I'm going to move to the next one, because remember, these are all multiplication. So these are all being multiplied together. So now I have a to the power of 2 times a to the power of 3, meaning I'm going to combine them together. So now I have a to the power of 5. So I'm going to put that next to my -14. Now I'm going to do the same thing with b. So I have b times a b, so they each have one b. Remember, anytime there's no exponent there, there's an invisible 1. So 1 plus 1 is 2, so now I have 2b. So my final answer is going to be -14, a to the power of 5, b to the power of 2. Our next rule is the power rule. This one is also pretty important. When we have parentheses here, and then these are going to be different. Instead of adding them together, I'm actually going to multiply them together. So I essentially have, x to the power of a times b. So I'm going to multiply them together. So let's look at our example here. We have -2 to the power of 2. Because remember, everything in the parentheses needs to be put to the power of 2. So now I have -2 to the power of 2 times, what is our m here is 5 times 2, which is going to give me 10. So now what I have here is -2 to the power of 2 times m to the power of 10 times m to the power of 3. So -2 times itself is actually going to give me a +4, because a negative times a negative is a positive. And I have 10 m's here and 3 m's here. How many total m's do I have? 13. And how I know that is based on our last rule up here, the product rule. If I have 2 numbers right next to each other, I'm going to add them together. Let's move on to the next few. Up next, we have our quotient rule. So when we have x's on the top and x's on the bottom, what we're going to do is we're going to subtract the top from the bottom. Okay, a great rule to keep in mind that I use is when I look at problems, which one has more, the top or the bottom? If the bottom has more, I know that all of my x's on the top are going to be gone, and they're just going to be on the bottom, and vice versa. So let's look at this example over here real quick. So I have 27 divided by 42. So these are going to get paired together because they're numbers, and these x's are going to get paired together when I'm dividing or canceling them out. So I know, that 27 and 42, they both go into, They both go into 3, so I'm going to divide both the top and the bottom by 3 because I want the smallest fraction that I can get. So this 27 divided by 3 is 9, and 42 divided by 3 is 14. I know that this is as far as we're going to get, so I know the first part of my equation is 9 over 14. And what I'm going to do here is I'm going to write my x's right next to it because I haven't dealt with them, and I want to make sure that I do deal with them. So I know that there are 5 x's on the top. So I have 1, 2, 3, 4, and 5. And I know on the bottom I just have 1. Okay? So this is a good strategy that you can use. You can draw them all out and line them up. But if you have large numbers such as 36 or 552, I don't think you would want to draw out all of those x's. So what I'm going to do here, since this is a smaller number, I'm going to line up my x's and cross them out. This is the same as doing a minus b, so 5 minus a 1. So I know that both of these are going to cross out, and I know that I have 1, 2, 3, 4 x's on the top. So my final answer is 9 x to the power of 4 over 14. So now let's look at our very special rule here, our negative exponent rule. So my negative exponent rule says that when I have a negative exponent, what I need to do is I need to draw a 1 underneath the x over negative a. And what I'm going to do is I'm going to flip these. I'm going to move the 1 on top and move the x to the power of a on the bottom in order to make it positive. We do this anytime that we have a negative exponent. You can just flip it onto the bottom, just move it straight to the bottom with all the other numbers, if there are other numbers. So let's look at our example here. I have negative 5x to the negative 2. What it states is I need to draw a 1 underneath the x to the negative 2 and take it straight to the bottom. So now what I have as my answer is what's left on top is a negative 5 over, now I have x to the power of 2. The reason I didn't take the negative 5 with me is because remember they're right next to each other and they're multiplied. The only thing I need to take down is the x to make it positive. If I take down the negative 5, it's not going to do anything and it's going to give me the wrong answer. So zero exponent rule is probably one of the easiest ones that you can ever see in the world, because anything to the power of 0, or sorry, to the exponent power of 0 is going to be a 1. So any answer that you see is going to be 100% 1. As long as it's all in the parentheses or all of the numbers are to the power of 0, then it'll always equal 1. So let's look at the example here. So first I need to do my rule where I multiply, which would be my power rule, because we have an exponent on the inside and an exponent on the outside, meaning I'm going to multiply. So I have w to the power of 8 over my original w power to the 8. Now I can find my top rule here, which is the quotient rule, which states to subtract the top exponent from the bottom exponent. So what I am essentially doing here is I'm taking 8 minus 8, which is going to give me a w to the power of 0, which we just learned is always going to be equal to 1. So now let's look at our next part of our problems. So moving away from exponents, we're going to do scientific notation. Now remember, for your notes, the decimal is the decimal in a whole number is at the back of the number. So it's always at the back. The decimal is always there for, 1, 65, 36. It'll always be there. So the exponent does not represent the number of zeros. Just to clarify, that's not how many zeros there are based on that exponent. It tells us how far to move. When the number is written in scientific notation, there's only one number in front of the decimal, and it's not a 0. So it can't be a 0, and it has to have one number. So this one right here, 3.4678 times 10 to the power of 3. Looks perfect. There's only one number in front of the decimal, and it's not a 0. This one right here, oh look, it breaks the second rule. the number in front of the decimal is 0. That can't be it, and neither can that one down there. 34.678. Again, the 34.678 is not considered 1 because it has more than one number in front of the decimal. So let's move on. If a number is written in scientific notation, so scientific notation is when a point something times 10 to the power of some number, okay? So when you see that times 10 to the power of some number, that's scientific notation. When it's a negative exponent, it means that the number is less than 1. So if you see a negative exponent, as you can see, 0.45 is less than 1 and 0.0056 is less than 1. That's why they have negative exponents. So if it's positive, it means it's greater than 1. So if I move this decimal one place in the positive direction, it's going to be 45. And for this one, 5.6 times 10 to the power of 4, that's going to give me 56,000. So positive exponents greater than 1, negative exponents less than 1. When we're changing a number from standard form, so like the number 45, into scientific notation, we need to make sure we count the number of decimal places the decimal was moved. So if we moved it 4 spaces, we need to know that number. If I moved it 1 space, and so on and so forth. If you move the decimal in the right, so if you hold up your fingers, which one doesn't make an L? If you move it to the right, the exponents are going to be negative. The exponent needs to be negative because it's becoming smaller than 1. Okay? If I move it to the left, the exponent will be positive. So standard form, if I move it to the left, it's going to be positive. If I move it to the right, it's going to be negative. So to see this from scientific notation to standard form, so I have 6,504,000. So what I would need to do is move the decimal place from the back here and move it as many times as I can. So it would look something like this. I would continuously move it until there's only one number in front of the decimal because that's what it states it needs. And it can't be a 0. So I did that. So if I was going to write it from standard form to scientific notation form, it would be 6.504. Now all these zeros I'm not going to include because this tells me how far to move. Okay. Now we have 0.00004708. Is that number larger than 1? Nope. So I know my exponent's going to be negative. And I'm going to keep moving here until I am in front of one single number that's not a 0, which would happen to be this 4. So I have 4.708 times 10 to the negative 5. So when we're changing a number from scientific notation, so times 10 to the power of something, to standard form, when we look at the exponent, and if it's positive, you're going to be moving the decimal to the right, making it larger than 1. Okay. Now, if I wanted to have a number smaller than 1, I would move it, it would be negative exponent, and I'd move it to the left, making it smaller. So to show you an example like this, changing the number from scientific notation to standard form, okay, this positive 4 tells me I need to move to the right because it's a positive exponent. I'm going to move 1, 2, 3, 4. And in case if there's no number here, what are you going to put? A 0. So now my number would be 45,760. And since this is a negative number, guess where we're going to move? Away from 1. So we're going to move it to the left. And I would add zeros, and my number would be 0.00004003. So I want you to try these on your own for your homework, and check with us in the middle of class and see how you're doing.